Hello everyone. This video demonstrates how the plasticity characteristics are determined on a given fine-grained soil sample. Plasticity characteristics are the basic measures of the nature of a fine-grained or cohesive soil. This helps to identify how the soil behave with the variation of its moisture content. In this test we basically determine the liquid limit and plastic limit, and calculate the plasticity index using those values. Liquid limit and plastic limit are often referred to as Atterburg limits, in recognition of their formulation by the Swedish soil scientist Albert Moritz Atterburg. In this video we cover the test procedure of liquid limit determination by Casagrande apparatus and penetration method, and also the test procedure for the plastic limit determination. The items needed to perform this test are sample containers and an electronic balance, 0.425 mm sieve, a mixing dish, a mold and a pedestal, a spatula, a squeeze bottle with distilled water, a glass plate, a Casagrande liquid limit device with grooving tools, a pentrometer, and an oven. Now let's see how the sample is prepared. Soil used in the test should be finer than 0.425 mm. A representative portion from the total sample sufficient to provide 150 to 250 grams of material should be obtained. Preparation of the sample may be done either by dry preparation method or wet preparation method. If material is finer than 0.425 mm, you can use the moisture material as the starting point of the test. If it has material larger than 0.425 mm, you have to dry it out in an oven, to be able to grind it down with a mold and pedestal. Then sieve the sample through 0.425 mm sieve. Soil sample of about 250 grams finer than 0.425 mm, obtained through above procedure should then be thoroughly mixed using a spatula. Mixed soil should then be returned to the mixing dish, covered to prevent loss of moisture and allowed to stand for at least 16 hours. First let's move on to the liquid limit test done with the Casagrande device and grooving tools. There are two types of grooving tools. One is for stiff material and the other is for soft. The two tools are set up to maintain the proper height of the material in the testing device. It will also give you a standard groove width. Before we start the test, we need to make sure that the device is calibrated for the proper drop height. We do this by using the back of the grooving tool, to make sure it is calibrated by sliding it underneath the cup, making sure the lifting mechanism barely touches the cup. Then a portion of the prepared soil shall be placed in the cup of the liquid limit device and spread in the cup to a depth of 10 mm at its deepest point. Also make sure to form an approximately horizontal surface. Care should be taken to eliminate air bubbles from the soil pat. But the pat should be made with as few strokes as possible. Then a groove should be made in the soil pat by drawing the tool through the soil, on a line joining the highest point to the lowest point on the rim of the cup. Then the cup shall be lifted and dropped by turning the crank at a rate of 2 drops per second, until the two halves of the soil pat come in contact at the bottom of the groove, along a distance of 13 mm. The number of drops required to close the groove should be recorded, and a slice of the soil be removed for the determination of moisture content. Sample should be taken from edge to edge of the cup to include the portion of the groove in which the soil flowed together. A spatula may be used for this purpose. We need a minimum of 3 samples. These samples will be based on the number of blows it takes for the material to flow together. Liquid limit is the moisture content of the soil when the groove closes with 25 blows. Therefore we would like to see 2 samples greater than 25 number of blows, and 2 samples less than 25 blows. Ideally all of them would be between 15 and 50 blows. Now let's see how the liquid limit is calculated from the test results. Since it is not possible to determine the moisture content exactly at 25 blows, the test is conducted as a multi-point test. Hence the test is conducted few times and the graph is plotted with moisture content and number of blows. Here note that the number of blows should be in log scale. Once the graph is plotted and the best fitted line is drawn, you can directly determine the moisture content corresponding to the 25 number of blows. This is known as the liquid limit of the sample. Now let's see how the liquid limit is determined using penetration method. The apparatus for the liquid limit test in this method consists of a pentrometer fitted with a 30 degrees cone of stainless steel. The cone and the sliding shaft to which it is attached have a mass of 80 grams. The soil to be tested is mixed with water to form a thick homogeneous paste and stored for 24 hours. The paste is then placed in the cylindrical metal cup, which has a 55 mm internal diameter and 40 mm depth. We should make sure that no air is trapped in the sample. Then the soil should be leveled off at the rim of the cup to give a smooth surface. Then the specimen is placed in the pentrometer and the cone is lowered, so that it just touches the surface of the soil in the cup. The cone should be locked in its support at this stage. Now set the displacement reading to 0. Then release the cone for a period of 5 seconds and its depth of penetration into the soil is measured. A little more of the soil paste is added to the cup and the test is repeated until a consistent value of penetration has been obtained. Then a sample is taken for the determination of the moisture content. The entire test procedure is repeated at least 4 times using the same soil sample but increasing the moisture content. The penetration values should cover the range of approximately 15 mm to 25 mm. For the calculation of liquid limit with the penetration method, the cone penetration is plotted against moisture content. Then the best straight line fitting the points is drawn as shown in the diagram. The liquid limit is defined as the moisture content corresponding to a cone penetration of 20 mm. Now let's move on to the determination of plastic limit of soil. The soil sample prepared for the liquid limit test can be used for this test. Here the moisture content of the soil should be reduced to a consistency at which it can be rolled without sticking. From this sample, about 2 grams should be taken and formed it to an ellipsoidal mass. This mass shall be rolled between the palms of hands and the ground glass plate. Mass should be rolled with just sufficient pressure to make it into a thread of uniform diameter of about 3.2 millimeters. A rod may be used to get a guidance about the size. Any crumbling of the thread should be observed during the rolling. This should be done over and over again, thereby reducing the moisture content till the thread crumbles, when rolled to a diameter of 3.2 millimeters. Once the thread is getting crumbled at 3.2 millimeters diameter, the portions of the crumbled thread should be gathered and placed on a container to determine the moisture content. The procedure should be repeated for another 2 grams portion of the soil from the original sample. This should be continued until the container has at least about 9 grams of soil. The same process should be repeated to obtain another container of at least 9 grams of soil. The moisture content from the 2 containers should be computed separately and get the average value to determine the plastic limit of the soil. Note that this is a single point test. Therefore, no graph is needed to determine the plastic limit. Once the liquid limit and plastic limit are determined, we can calculate the plasticity index, which is simply the difference between liquid limit and plastic limit, as shown in this equation. The obtained plasticity values are essential to characterize fine-grained soil and classify them according to standard classification systems. One such common standard is Unified Soil Classification System, which uses the plasticity chart to classify the fine-grained soil. Thank you for watching the video. We hope you understand how the plasticity characteristics of a fine-grained soil are determined.